All right, IM2 classes. Today we are talking about greatest common factor and factoring by grouping. Let's get right into it. Um, so we've done some work in class with factoring. So what we're going to do is we're going to be taking this quantity and splitting it into two smaller quantities that would multiply together to get there. Um, Again, stuff we've done in class. So say, just as an example, if we took a number like 15, if we want to factor 15, we would split it into 3 times 5. So 15 factored is 3 times 5. We are going to be doing that same thing with this binomial here. We're going to split it into two smaller quantities that multiply to get there. How we do this, we want to look at these things and we want to factor out what's called the greatest common factor. So, greatest common factor is the largest thing that those two terms have in common. All right. So, we'll be referring to this as the GCF in class and from now on because I don't want to say greatest common factor every single time. So it's going to be GCF. Uh, First, you want to look at the numbers. This has a little bit of invisible math here. The v to the 6 has a exponent or a coefficient of 1. Um, so the 6, the numbers aren't going to have anything in common, but if we look at the v's, this is v to the 6, this is v squared. They have at least two v's in common. So what I'm going to do is divide both of these by v squared. All right. Uh, and this is going to give us our factors. So the greatest common factor here is v squared because it's the largest thing that both the terms have in common. So it'll be v squared. And then what's happening is we are doing distribution in reverse. We are undoing the distribution property. So I'm going to divide both these terms by v squared. So v to the 6 divided by v squared is v to the 4th. 2v squared divided by v squared. The v squared is cancel each other out. So you're left with just 2. So there we go. We have completed the greatest common factor, right? So what we have here, so example, if it was like the 15, we took our larger quantity, v to the 6 plus 2v squared, and we are doing splitting it into two smaller quantities that multiply together to get the original binomial there. So it's just we are factoring it, splitting it into two smaller things. So if we were to distribute the v squared, we would get back to the original. All right. So let's look at another example with some numbers. So here, same thing, greatest common factor. With the numbers, what you want to think about is what's the largest number that divides both 56 and 7 evenly. So we can divide 56 and 7 both by 7. And then how many n's do they have in common? This says n to the third, n squared. They have at least an n squared in common. So we're going to factor out an n squared. So divide both of those. So outside the parentheses, going to be 7n squared. Inside, 56 divided by 7 is 8. N cubed divided by n squared is just n. Plus 7n squared divided by 7n squared. Whenever you divide something by itself, it's 1. So we put in a 1. And that's it. We're going to skip ahead a little bit. Now doing the same thing with trinomials. All right, so with trinomials, what we want to do is same thing. We're going to look at each term. What is the largest number that divides 15, 5, and 5? What's the largest number they have in common? That's going to be 5. So we're going to divide all three terms by 5. Then I'm going to look at the variables. V is the 4th, V, no V. Since the 10 doesn't have a V, they don't have any V's in common, so I can't divide by a V. So the GCF, the greatest common factor, is just 5. And then I'm going to um, divide here. 15 divided by 5 is 3, so it's 3v to the 4th. 5 divided by 5 is 1, so that's just going to leave the v. Plus 10 divided by 5 is 2. We're done. Let's do another one here. What's the largest number that divides 12, 8, and 8? That's going to be 4. I can divide all those by 4. This is n to the 6, n, no n. Since all three terms do not have an n, I can't divide an n. They don't have any n's in common, so the GCF is just going to be 4. So it's going to be 4 outside the parentheses. 12 divided by 4 is 3, so it's 3n to the 6. 8 divided by 4 is 2, so 2n. 8 divided by 4 is 2 again. So 3n to the 6 plus 2n minus 2. Those are our factors. One more. We'll do this one because this one does have, each term does have a variable. So here, it's helpful to look at the numbers first. So what's the largest number that divides 25, 5, and 25? Those all have a 5 in common, so I can divide out a 5. R to the 8th, R to the 5th, R to the 3rd. You can always divide by the variable with the lowest exponent. So I'm going to divide by R to the 3rd. That's the number of R's they have in common. Now divide this out, so it'll be 5R to the 3rd outside parentheses. And then inside, 25 divided by 5 is 5. R to the 8th divided by R to the 3rd is R to the 5th. 5 divided by 5 is 1, plus R to the 5th divided by R to the 3rd is R squared, plus 25 divided by 5 is 5, and then the R to the 3rds cancel out. So 5R cubed times 5R to the 5th plus R squared plus 5. Now we are going to actually skip ahead because here we go. Factor by grouping. What we're going to do is we are going to factor these polynomials. We're going to split it down into two smaller quantities that multiply together. We're going to use that GCF here. So first thing we are going to do is we are going to group the first two terms together and the last two terms together, right? And then you are going to find the greatest common factor of each of these groupings. So I'm just going to do one big line on the grouping. So the greatest common factor between p to the 3rd plus 2p squared. I can divide. They don't both have coefficients, so it's just the variable. I can divide by the variable with the lowest exponent, so p squared. So on the first grouping, the factors are going to be p squared times p cubed divided by p squared is p, plus 2p squared divided by p squared. Those p squareds cancel out. So it's p squared times p plus 2. Plus, on the next grouping, the greatest common factor between 3 and 6 is 3. This has a p, this doesn't, so I can't divide out a p. All right. So on this grouping, the factors are going to be 3. And 3p divided by 3 is p. 6 divided by 3 is 2. Notice here, and this is what we want to look for. These are identical, p plus 2 and p plus 2. That is what we want. If those are not identical, two things might be true. One, for this assignment, really, and for most of them, you made a mistake and you need to go back and check your work. The other possibility is this just doesn't factor. We'll do some examples on those, but we're not going to see too many of those in class. So if these don't match right here, you made a mistake, you need to go back and check your work. The last step to factoring by grouping is we need to now regroup our factors. So how this works, our factors are going to be, we're going to have two factors. All right. The first factors is the greatest, our GCFs grouped together. So the first factor is going to be the p squared and the 3 grouped together. So p squared plus 3 is grouped together. And then the next factor is just the p plus 2. And those are our two binomials. So if we were to multiply this out, either using FOIL or distributing or the box that we've gone over in the past, we would get this original. So the 4-term polynomial factors into two binomials here. And that's how that works. Let's do another example here, and then we'll call it. So again, the first step is you group the first two terms together and the last two terms together. Then you're going to find the greatest common factor on each grouping. So on this first grouping, the largest thing that divides 2 and 6 is 2. And then with the variables, you can always divide by the variable with the smallest exponent, so 2x squared. So the factor from that first grouping is going to be 2x squared. Left in the parentheses, 2x cubed divided by 2x squared is 1x. Minus 6 divided by 2 is 3. X squareds cancel out. So 2x squared minus 3 plus x minus 3. That does not have a greatest common factor. X and 3 have nothing in common. When this happens, when we're factoring by grouping, what you want to do is divide by 1 because when we regroup, we need another GCF to group with the first one, the 2x squared. So we're going to divide it by 1. So take that 1 out and then bring it down. So notice here are terms inside this set of parentheses are identical. We did a good job. And so here, now when we regroup, we're going to have our two binomial factors. Again, the first grouping is just the GCFs grouped together. So that's going to be 2x squared plus 1. And then x minus 3. And that will do it. Next time we'll do more factoring.